How can I apply the Pythagorean theorem to real situations? So here's an example. This one's a bit tricky because it says it's how tall was this tree. So in this picture, you can see this wonderful drawing I have of a tree that fell down, right? So if we have a right angle where the tree hits the ground, what we have is a right triangle, which means we can use the Pythagorean theorem. But in order to figure this out, we have A, B, and C, but keep in mind the tree's height is actually going to be A plus C. So at the end, once we figure out C, we can then figure out the original height of the tree. So I use A squared plus B squared equals C squared. A is going to be 6, so it's 6 squared. I was able to measure that. You can measure on the ground the 10 feet from the base of the tree to where the top of the tree is at the ground. So 10 squared. 6 squared is 36. 10 squared is 100. That's still equal to C squared. I add together, get 136, and take the square root. When I put that into my calculator, it's 11 and 66 hundredths is about C. Now that was a lot longer, but I rounded that decimal. So 11 and 66 hundredths feet would be what C is. However, remember I have to add that to the 6 feet that's still standing upright of that tree. And so I go 6 plus 11 and 66 hundredths is about 17 and 66 hundredths feet for this tree that fell down. So that's one way to apply the Pythagorean theorem. Another way would be, say I'm installing a ramp, right? You know, there's stairs. Maybe like my grandmother's using a wheelchair now, so she needs ramps on the stairs outside her house or something, okay? So let's install this ramp. The stairs are 5 feet high, and I want to be 10 feet away from the bottom of this, from the top of the top stair. I want to be 10 feet away. So how long of a ramp do I need to install? Well, I just do A squared plus B squared equals C squared because we have a right triangle here. And so the A squared is going to be 5. This will be 5 feet as well as this. And then the B squared is going to be 10. So I do 5 feet squared is 25, and 10 feet squared is going to be 100. I add those together to get 125, and then I take the square root of 125, where C would be about 11 and 18 hundredths feet long. So that's about how long I would need to make this ramp. There's an example, right? However, sometimes we might need to adjust our plans because in real life, things aren't going to always be as neat as clean. Oh no, we only have 11 feet of ramp. So we want to make this ramp. I want to know, can it still fit? A couple things I might think about is these stairs. I say they're each 1 foot long, so it has to go out at least 2 feet. So if I know I have 11 feet of ramp, this is still 5 feet. I'm still dealing with a right triangle. But how far out would the ramp end at, right? Like how far out there? So then I can say, okay, well, let's see. We do A squared plus B squared equals C squared. In this case, we don't know B. A is still 5, so 5 squared. C, we know it has to be 11 because that's how much material we have to build the ramp. Then we do 5 squared is 25, 11 squared is 121. I already went and took away 25 here, so I did 25 plus B squared minus 25 equals 121 minus 25. That leaves me with B squared equals 96. I can now take the square root of both sides of the equation. The square root of B squared equals the square root of 96. That leaves me with B is about 9 and 798 thousandths as an approximation for B. So if this has to be 2 feet away from here, it's going to be not 9, almost 10, just like the original problem, feet away. And so it should fit. It should still fit there. So that's just another way we can apply the Pythagorean theorem to real situations.